All right, today we're going to be dealing with something called tangents. All right. Now, what you need to understand about a tangent line or a tangent segment is the fact that it rests on a circle. It does not go through the circle. So on problem number 2 that we did yesterday, what was our tangent segment? And P. Now, there's a special relationship that happens with all tangent segments or lines. They are perpendicular to the radius of a circle. So let's just call this the radius, because it is. And this is a radius, and that tangent line they always form what type of angle? 90 degrees, right there. Now, another thing you need to understand about tangent lines. If I drew another line that was perfectly tangent to this circle, let's make it the same color. So from P, if I drew another line that was perfectly tangent to the circle, like right about there, if I drew another radius right there, once again, what type of angle would it make? 90 degrees. And by the way, this tangent line would be equal to this tangent. That's what we're dealing with in problem number 1. Does everybody see this line right here? That is tangent to this part of the circle. I kind of drew a circle to kind of represent the ponds. Okay? So what we're trying to understand, they're ponds. They're not rocks, they're ponds. If you read the word pond. How about this? Why don't you read the word problem, Jacob? Go ahead, read. Read. Go ahead.
A landscape architect is planning to pave 2 walking paths beside 2 ponds.
Ooh, 2 ponds. 1 pond. 2 ponds.
Find the value of X and Y. What is the total length of the walking path?
All right. So we're going to find the total lengths of the walking paths, and we're also going to find the value of X and Y. Does everybody see how X plus 250 is going to equal this 4X minus 500? Like this path is going to be the same as this path. So what we do is we set them equal to each other. We say 4x minus 500 is going to equal the other path, which is x plus 250. And now what do I expect you to do as a high school student? Solve for x. Once you solve for x, everybody, then whatever you solve for x, take it in, keyword.
Run?
No, don't run with it. Plug it in. If you plug it in here, you can also plug it in where? Right there. Here. We'll put plug in. Now, something you need to be aware of. Does everybody see this distance called x plus 25? That distance is the same distance as another distance called y. So if you solve for x correctly, and then you plug it in right here, just remember, you should know what y is equal to. What is y equal to? X plus 25. So solve for x, and you'll get a value for x. Y will equal whatever x plus 25 is. All right, so once you find x, just plug it in right there. Now that's one of your answers. What do you got to solve for? You got to solve for x and y. What's the other thing that you need to do? Find the total distance of the pathway. This is what I want you to find. I want you to find the total distance from here and right there. That's basically the distance that I want. Obviously, you don't know what these are, so from here to right here, and from here to right here. So once you find this, what could you do? Just multiply it by 2, and that gives you your total distance. I'm not going to give you the answer for this one. I'm expecting you to know how to do what? Solve for x and then plug it in. Solve for x, plug it in. Good luck. Well, I guess since you're watching the video, I might as well go ahead and do it. We're going to take away an x from both sides. We get 3 x's. I'm going to add 500 to both sides. And I hear out of the corner of my ear, 750, also known as jerk. Okay, 3x equals 750, and then he's going to tell me to do what to both sides? Divide by 3, divide by 3. And x equals 250. But that's not my final answer. So x is 250. But I got to add 25 to it, and y equals 370. So there's my x and there's my y. So that's the correct answers for x and y. But that's not the last thing I need to do.
You gotta plug it in.
I got to plug it in. So I got to plug in a 250 right here, and I got to plug in a 250 right here. Now, what does that make this right here? That makes that a 500. And what does that make this right here? Yeah, that's a 275. So if I add 775?
Yeah.
775 represents one side of the path. But you have to multiply it by 2. And then you get a what?
1,550.
Now is this in feet, yards, what does it say? Yeah, we don't know, does it? We don't know. Just put units, just put units. Alright? It doesn't say miles or feet or whatever. So the path is what? 1,550. We'll just call it units. Whatever the unit is. It could be feet, it could be meters, it could be yards.
Miles.
But hopefully not miles. That'd be a long. No, probably not miles. Being that 1,550 miles would get you a long ways away. Like in another state. Like you'd be getting to California. Yep. That's a big pond if it's over to California.
It's not a pond
It's
anymore.
not a pond.
It's an ocean. That's fresh water.
All right, there we go. Number 3. Number 3. What are we trying to find, everybody? We're trying to find the value for x. Now, what does RS represent in this problem? Anybody know what we call RS? By the way, what's the title of our paper? Ooh, that's
It's a
right.
tangent line.
That's the tangent segment. All right, so that's the tangent. Now, what does this part of the problem represent? What does that represent? The radius, right. And what do radii always form with a tangent segment or line? A 90-degree angle, so 90 degrees like this. You're making noise when I'm recording. It does not make me happy. Apology accepted. Now put it down. Really? Now, what does the green segment represent, everybody? What does the green segment represent? The hypotenuse, you're right. So all of that is the hypotenuse. Now check this out. That's 8. What's this distance from here to right there? I'm not going to tell you. You're right. That's 12 right there. So what is the distance of our pointing? That's right. Our whole hypotenuse has to be 20. Now, if you guys can't see it, here's another right triangle that represents your problem. Right here. Here's a right triangle. We're going to call this side 20. We're going to call this side 12. We're going to call this side right here x. And you better, at this point in your life, you better know how to use the Pythagorean theorem to find x. Just remember, x squared will equal 20 squared minus 12 squared. This is from, we can call it b squared equals c squared minus a squared. Okay, that's another way of looking at it. So what do I want you to do? Use the Pythagorean theorem and solve for x. Now, if you use the Pythagorean theorem correctly, you would have gotten 400 minus 144, which gives you a result of 256, which is equal to x squared. But we all know in this class that you have to do what?
Oh my God.
And no, it's just Mr. Newton. We just share a reason. And x is equal to 16 units. That's your answer. Now, number 4 is a little bit trickier. Uh-oh. we need to find something called x on this one. Now, in this problem, what does this x represent? It is definitely not the tangent. What's the tangent segment? Do you know what the tangent segment is? W. U is the tangent segment. Anybody know what the length of the radius is? 7. So what does the radius form with the tangent segment? A right angle. So if that's the 90-degree angle, what does it mean the distance from W to V is? That's the hypotenuse. Is it important to know what side is the hypotenuse? Yes, it is. Do we need to find the hypotenuse in this case? Yes. That's the hypotenuse. Our angle, everybody, is what? Our angle is 65, which means this side would be called the... Yes, that's the opposite side. Which means this 7 has to be our... S adjacent. So by the way, we have our adjacent side. We are looking for our hypotenuse. So we have our A. We are looking for H. Together they make So we're not going to use so. Oh wait, yes we are, because look, it's the what? The A and the H. I tricked you. So see, everybody see the A and the H? A and the H. Which means you're going to use what? Cosine. So here's what you're going to do. You're going to write the cosine of what angle, everybody? What's my angle? 65. Yes. Equals my adjacent side, which happens to be a 7, over the hypotenuse, which is x. Oh, that's the x, yes. So it says 8 over 1. Yeah. Now, everybody, that's how you set up the proportion. But you need to look at it carefully because it doesn't just automatically give you the answer. We actually do have to do a little bit of cross multiplying. The only time you ever use the inverse is when you're trying to find the measure of the angle. That's what we're eventually going to have to do. You have x times what? X times the cosine of 65 degrees is equal to the number 7. So in order to solve for x, in order to find that number, I have to divide both sides by the cosine of 65 degrees. Now, in order for this to work, what does your calculator have to be in? Yes, degree mode. It must be in degree mode. Now, I just want you to round your answer to the nearest tenth, and that will suffice. So make sure your calculator's in degree mode. So we do 7 divided by cosine 65. Press enter, and you get 16.6. So that's all you got to do. Yeah. So in this particular case, x is approximately equal to 16.6 units. That's why you get the double squiggly. Double squiggly line. All right. You guys need to be doing all the problems. The next problem we're going to do is problem number 7, but we're not going to start it until you get the other problems done. All right, problem number 7 is a little bit trickier. You will notice right here that this distance from right here to right there is x, which means this distance from right here to right here is also x. That is pretty important right there. I'm going to draw in the tangent segment from E to D. All right? That's the tangent. Okay? X is the radius, which means this right here, this is where the right angle is. Okay? So, from E to G, from E all the way to G, what does that represent? That represents the hypotenuse. So here's what I need you guys to write down to help you guys give a map to the problem. Here we go. Write this down. From G to D, that segment, okay? If you take that segment and you square it, and you add from E to D, that segment squared, that is going to equal your hypotenuse, which is from E all the way to G squared. So this segment squared plus this segment squared equals this segment squared. Okay?
So you do the square root of at the end.
At the end. We'll worry about that at the very end. But right now we got to get it set up. Now, what is the distance from G to D, or from D to G? What's that distance? Right there. What's that distance? Sure we do. So we're going to say x, and what are we going to do with it? We're going to square it. Plus. What is the distance from E to D? 16.
Squared.
So we're going to square it. Equals. Now, this is where you got to be careful. What is the distance from E to G?
12 plus x.
12 plus x. I'm just going to write it a little bit easier. I'm going to write x plus 12. Just to, and I got to make it squared. Okay? Now, here's what we have so far. We have an x squared. 16 squared is 256. Now, there is a fast way, everybody. There is a fast way to take x plus 12 and multiply it to another x plus 12 without having to do the FOIL method. Okay? There's a lot faster way. All you have to do is know that it starts with an x squared. What's 12 plus 12?
124.
So that's going to make this a 24x in the middle. What's 12 times 12? 144. So that goes at the very end. Now, for those of you who are like, what the heck did you do? I took 12, I added it to 12, got a 24x. Took 12, multiplied it to 12, got a 144. That's without having to do the FOIL method that you guys learned in Algebra 1. Okay, where you do x times x is x squared. X times 12 is 12x. 12 times x is 12x. 12 times 12 is
44.
All right, so when you add all those together, you still get the same answer.
I forgot about that.
Don't ever forget about it, because you're going to need it, especially when you hit Algebra 2. All right, so here's what you got. You got x squared plus 256 equals x squared plus 24x plus 140. Thank goodness. Look what you have on both sides. Not just an x. What happens to all the x squareds? They disappear. So here's what you have left. You've got a 256 equals 24x plus 144. So at this point, all you have to do is solve roots. No, there's no square roots. There's nothing being squared here. You just solve for x. Which means you just take away 144 from both sides. That's a 2. That's a 1. That's a 1. It equals 24 x's, and then you divide both sides by 24. And x will probably equal 4.6 repeating in the graphing calculator. What does that actually mean, everybody? That means it's 4, and what fraction always goes with 0.6 repeating? 2. And that's your final answer for x. 4 and 2/3. If you don't believe me, 112.
Divided.
24 is 4.6 repeating. Yes, the calculator will round to 7. Technically, that's a 6 that goes round. All right. Now, I'm just going to show you one problem and one problem only. For number 8, your job is to do the rest. Look carefully at this. If this line, if BC is a tangent to this radius, what type of triangle must we have? We must have a what? Right triangle. If we don't have a right triangle, then this line segment BC is not considered to be tangent. So here's what I need you to do to test if this is indeed a tangent segment. You must test, is 16 squared plus 30 squared actually equal to 34 squared? If this segment squared plus this segment squared equals this segment squared, then the answer is yes, it is tangent segment. If it's not, then no. 16 squared is?
So, 2.
Yeah, I was right. Yes, I was just making sure somebody stopped making noise. 30 times 30? Yes, that would be you. 34 times 34? Is it 1,156?
Yeah.
When you add these together, you get 1,156. Now, everybody, if this side equals this side, then that is a right triangle, which means this segment has to be tangent. So your answer is this. Yes. Right? Yes, segment BC is what? It is a tangent segment. But yes, BC is tangent. If this side does not, for some reason, if this side does not equal the other side, then that is not going to be a tangent segment because it doesn't make a right triangle. That's what you're doing on the other problems. So right now I'm going to zoom out. All of these, you got to make sure things are what? Going to work. Either they're going to work or they're not going to work. All right, determine whether each segment is tangent. Which segments are the tangent segments that you got to test? I'm going to show you the ones. Is that the tangent segment? Is that the tangent segment? Is that the tangent segment? And is this the tangent segment? Good luck. That's what you're supposed to do right now. Number 9 is kind of tricky if you think about it. It's asking us. It's asking us is 3 squared plus 5 squared equal to 4 squared. If this is tangent, they're saying that this is the hypotenuse. If that's the tangent segment, then we're checking is 3 squared, which is a 9, plus 5 squared, which is a 25. Is that somehow equal to a 16? Is 34 equal to 16? No, it is not. So therefore, no. DE is not. It's horrible handwriting. Sorry.
Can we guys say that? And then do our, or you have to say that?
Well, it just depends. Do you want to do what the teacher asks you to do or not? Okay. So DE is not tangent. How do I know that? How do I know I was testing for DE? How do I know that? Because it tells me. Notice, all the ones that I highlighted. See those? Those are the ones that we're testing to see if they are tangent. That's what you're doing. Very last problem that we are going to do today. We're going to do problem number 12. Now, problem number 12 says find the perimeter of the polygon. So we got to find, just so you guys know, on problem 12, you find the perimeter of triangle, we'll call it PLM. PLM. We're going to find the perimeter of P to L to M. Now, something that you need to be aware of, there's the right angle. You need to know that this distance right here is going to be the exact same as this distance right there. Those are both radii of the circle. And you also need to know what the hypotenuse of this right triangle is equal to. All right? So I'm going to call this x. I'm going to call this x. I'm going to call this green segment from P all the way to M. I'm going to call it x plus 2. And if this is a right triangle, which it is, you can see the right angle. I know that this side squared plus this side squared is going to equal that side squared. So what you need to do is this. You need to take x, and you need to square it. You need to take 10, and you need to square it. And you need to set it equal to x plus 2 squared. Now, what does x plus 2 times x plus 2 become? It becomes x squared. What's 2 plus 2? 4. 4 x's. What's 2 times 2? Also 4. Just so you know, x plus 2 times x plus 2, if you do the FOIL method, becomes this right here. Once again, what do you have on both sides of the equal sign? What do you have on both sides of the equal sign? X squared. So I'm just going to slash those out. So you have 100 equals 4x plus 4. If you take away a 4 from this side, and you take away a 4 from that side, you get 96 equals 4x. Divide both sides by a 4. And you get 24 is equal to your value for x. Which means this value right here is a 24. This value that you have to plug in is a 24, but 24 plus 2 makes that a 26. So what are the three sides? A 10, a 24, and a 26. What do you have to do? You need to add all of those sides together. And when you add 10 plus 24 plus 26, what do you get? A total of 60 units. And that's the perimeter of that triangle. And that's how you set it up. That's how you solve it. That's what you're going to do more of on the back page. That's how you set things up. If you don't know the length of the side, but you know that the sides are equal, what can you call them? You can call them x. So if this side is congruent to this side, that means, by the way, always search for the distances of the radii.